Now we're going to look at SIR models in terms of phase planes. As a very quick recap, we use the SIR model as an epidemiological tool to see how infections spread. This is because we can look at populations in terms of three categories of individuals who are susceptible, infected, and recovered. So what are phase planes? Phase planes are a visual tool to be able to see the interaction of variables within dynamic systems. And we do this because instead of tracking each variable separately over time, as we have been doing, we actually want to see the relationships between two variables. And in the case of the SIR model, we usually look at the relationship between susceptible individuals and infected individuals. Some of the benefits of using phase planes is that they can reveal both patterns and relationships within the data and specific points called equilibrium points that are important to the system. In addition, it can offer insights into the behavior of the system. Let's have a look at some of the main features of phase planes. I have an example here. So first of all, we want to look at the axes. We have the two variables that we want to plot a relationship against, so the susceptibles and the infectives. And then we have the trajectory, this curve over here. And that's important because we can see how the number of susceptible individuals and the number of infective individuals change relative to each other. But how does the system move? In order to know that, we have to look at our directional arrows that you can see over there, and we can see how the system moves through its states. So you might start at the bottom over there with mainly susceptible individuals, and then as we go, we can see that the number of infectives increases as the susceptibles decreases, and that's showing that we have a high infection rate at that point, and then we can see at the end that it starts to recover. Lastly, we look at what are called null clines, and that's this part over here. And that line is telling us where the slope of our trajectory is equal to 0. And that's important because that's the point at which we'll start decreasing in terms of number of infected individuals. Now that we know about null clines, what we want to do is find the intersection of these null clines because this gives us our equilibrium points. And equilibrium points are very important as we can understand the long-term outcomes of our model using them. So it's essentially parts where the epidemic will stabilize or die out, where everything, all of the slopes are equal to 0. So when we look at the intersection of these null clines, we have to set the derivatives of I and S to 0 to find these points. And as you can see in these equations, we get the following results where either I has to be 0, so there's no more infected people possible, or there have to be no susceptible people for that S equals 0, or our S can be gamma over beta, so our recovery rate over our transmission rate. So what we can do now is see what our transmission rate or beta value and how it changes can impact how epidemic will spread using our phase plane. So as you see at the moment, if you have a low beta value, you can see that the slope is very flattened. And as the beta value increases, we can see that we have a much higher peak. And this is now showing us that our number of infectives can be very high at one point because if the transmission rate is very high, there are lots of people at one point in time who will all have the virus and be infected. Whereas if we have a very low transmission rate, it's very difficult for the virus to actually start propagating and infect many people. Then we have our second rate, which is our recovery rate, which is gamma. So we can see here, if we have a very high gamma, that means that the recovery rate is very short, so a lot of people can very quickly recover. And so we, again, have a very flat graph because it doesn't take long for people to get over it and they won't infect other people. And here, we have a very low gamma, so that means the recovery rate is low. So a lot of people, once they get infected, will take a long time to recover, so they stay infected and will keep infecting other people, so you get a very high peak. So low peak for the high recovery rate, and you'll have a high peak for a low recovery rate.